Hello, this is Whitney Otan, Professor of Geology in the Department of the Earth Sciences, and I'm here today to explain to you this week's laboratory exercise in ESC 195 Natural Disasters. This week's topic is snowpack monitoring. And as you know, in the wintertime, as snow falls in cold and mountainous landscapes, it can accumulate and create thicknesses of snow that's stored along hillsides, mountainsides, and across terrain, and this storage can last for several weeks to several months depending upon the climate in the local area. Well, this snowpack is important for a variety of reasons. Number one, it is storage of water in the form of ice, and this will eventually melt and become runoff to our streams. So an important part of understanding snowpack monitoring and melting is to be able to understand how much water is available to run down our streams during melt, and potentially it gets stored in our reservoirs and water supply structures that we use for human consumption. Secondly, the other important part of snowpack monitoring is if we have rapid melts, if we have drastic changes in temperature, and sudden melting can produce catastrophic flooding downstream. So basically, in order to understand the distribution of snow in a watershed, we can begin to make predictions as to what might happen when the snow melts. In order to understand this, we need to understand first the thickness of the snow that's accumulated in a watershed, where the snow is accumulating, and what is the quantity of liquid water that can be produced when the snow melts. So the accumulation of snow in a watershed is typically not uniform everywhere. First things that happen is that some areas receive greater amounts of snowfall than others. Secondly, some areas that receive snowfall may melt quicker than others. So this type of pattern tends to be associated, especially in mountainous areas, with things like elevation. The higher the elevation, the longer the snow will remain on a mountainside. And then secondly, the aspect or the orientation of the hillsides. North-facing slopes will typically hold snowpack for longer periods of time than south-facing slopes. So by understanding the nature of the accumulation of snowpack on mountainsides and then monitoring weather patterns to see when temperatures get warm enough to melt and how quickly the melts occur, give us the ability to monitor and also predict the quantity of water that's available for runoff in spring melts. What we're hoping for generally is a relatively slow melt that allows water to move through watersheds without creating floods and creating disaster. However, that is not always the case. So what we can do, as I said, is store water in watersheds if it melts at slow enough rates, but if snow melts under very rapid rates, we have to prepare ourselves for the potential of river flooding and the disasters that can accompany river flooding. So with that, hopefully you'll enjoy this week's exercise. Have yourself a nice day. This is Whitney Otan signing off.